here. And I'm going to move this out of the way. There we go. All right. Here's a problem, and it's all you doing the practice, learning how to read these questions. That is why you have already done the OWL. Without the OWL, you're going to be lost. Because the OWL really does challenge you in this chapter to do what you need to do to get yourself ready to understand equilibrium. And let me just, Ms. Long and I had a good long talk the other night. This chapter is hard because of understanding how to read the questions. That's why we have to practice so we just get used to the reading. But if we don't have the foundation laid for us now, that next unit, which is the hardest unit you will ever encounter, you will fall apart. So if you don't understand ICE inside and out, particularly for, not so much the KSP, but the KC, KP part, then the next unit, which is 2 chapters worth, and it's the hardest part of AP chemistry, you will fall apart. So that's why it's been very important that you do the OWL in chapter 13 and you do the OWL in chapter 16 so that you've really got that practice underneath your belt. And then I've added to that, since we're done with the OWL, I've added the fact that I created a worksheet for you to do called the review sheet, and that I gave you those 4 FRQs to do, and then I gave you those virtual labs to give you some practice with some KSP and Le Chatelier's principle to give you that practice. You cannot achieve equilibrium without practice. It takes practice. That's why this question is very important for us to walk through it, because it's a different kind of word. Yes, ma'am. I've got it ready to post on here, but yeah, for both the FRQs and the review sheet. Yes, yes. I just don't want people copying, because that's going to do you no good. You can go Google the FRQ answers all over the web. You can go get them, and you can put them down on your paper, and you have wasted all your precious time. Because it will do you absolutely no good to do that. Now, you can do that, and I won't know the difference, right? But in your heart, you'll know the difference. Who you are is who you really are on the inside. You know that, right? You're doing the right thing when nobody's looking, right? Okay, just saying. Because in college, you got all kinds of time and ways to cheat, right? And then you might be like my college roommate, my freshman year, my best friend from the age of 2. And at the end of our freshman year, come back. You can't come back. You can't ever graduate from UNC Chapel Hill, little girl. She has never gotten her college degree, and we're 48 years old. Absolutely. She's been my best friend since 2nd grade. Okay. All right, so this question says, a saturated solution is prepared by adding excess PbI2 to distilled water. Stop. You're taking a bunch of PbI2 and you're adding it to distilled water. It's an insoluble substance, yet X of it is going to fall through the cracks. Okay, so look at that reading. A saturated solution, that means to reach an equilibrium spot. That occurs by adding lots, we call that Z, lots of PbI2 to some water. That means no ions present. Yes? Okay. And the next part says the concentration of the lead ion in the saturated solution. When? At equilibrium is this. So that means at equilibrium. The Pb plus 2 value is that. All right, so here if I put underneath here Z and 0 and 0 and minus X and plus 2X, that allows me to reach equilibrium. So how much Pb plus 2 do I have at equilibrium according to my little ice chart right here? I have how much Pb plus 2? According to my ice chart? X! In your ice chart, with no ions present, distilled water, would you have X for Pb plus 2? How much would you have for I minus? 2X. And which one of those did they give me? They gave me X. They gave me the lead value at equilibrium. So according to my little ice chart that I can always do over to the side to help myself if I need it, they gave me X in this question. I can go find KSP now, can't I? If I know what X is, if I know what the lead to ion concentration is when it's saturated, and saturated means when? At equilibrium, then I know the value of X. Do I also then know the value of I minus? I do, it's just 2X, isn't it? It is. Okay, notice first question, write the equilibrium constant expression for the equation. That's easy. We've been doing that a lot now. PbI2 solid in equilibrium with Pb plus 2 I minus. That's all they're asking for in that part. In this part, they're just saying, do you recognize that from your ice chart that the I minus is going to be twice the lead 2? Do you recognize that the I minus is simply going to be 2x, and since we know x, it's going to be 2 times 1.3 times 10 to the minus 3, thus it's going to be 2.6 times 10 to the minus 3. It's just going to be twice. Now they could have given me I minus, and if they did, they would have given me 2x instead of x. Now you go find the KSP, because there's 2 ways to do that right now. The last question on there is calculate the value of KSP. And you can do that on your own. Not supposed to go look it up. You won't be able to go look it up unless you do my test. Because they already gave me that part. Leon is helping me out just a little bit here. It says the expression, not the equation. They already gave me the equation, isn't that? And I think I get 8.8 times 10 to the minus 9. For my KSP, or 9.0 times 10 to the minus 9, something along those lines. Now, is that the only way to get KSP? To plug in the lead that they gave me and then to plug in the iodine that I found? No. Kelsey, what's the other way? Okay. KSP is also, because it's a 1 to 2 relationship, 1 to 2 is going to be equal to 4x cubed. And since I already have x, I could have said KSP is equal to 4 times 1.3 times 10 to the minus 3 molar cubed, right? I would have gotten the same answer. Could have done either way. Either way is a valid way for showing them you understand this problem. Either way is valid. When you see that they gave you lead and thus they gave you x, you can jump all the way over to 4x cubed to get your KSP. You can't. Either way is a valid way. That's why I wanted to show you both ways. They kind of set you up for you to show them this way, but it's okay for you to show them also this way because it's a valid way for getting KSP. 8.8 times 10 to the minus 9, or 9.0 times 10 to the minus 9. Yes? Okay. Bottom part, I want everybody to read B. All I want you to do is read it and think. Here we go, and ask this question. But really technically, the only difference from the reading up in A and the reading down in B. The liters. They didn't give me the value of PB plus 2 because they're asking me. Since I have the KSP now, they're asking me. It's kind of a little flip from what they asked me up in A to finally get KSP because they gave me PB or gave me X. Here they're saying, okay, what's going to be the PB because you already have the KSP if you change the volume. Now, let me ask the question. What changes the value of KSP? Only a temperature change. Okay? So in this question, how am I going to obtain X? How am I going to find X, which is the amount of PB? From my KSP. Has my KSP changed? So is my X value going to be different from 1.3 times 10 minus 3? That's what they're asking. Yes, the volume is going to be different, but is that going to change your value of X? No. So what will it change? It will change the number of moles. It'll be double the number of moles because it's double the volume. But will that change the molarity? Oh no, if I double the moles and double the volume, is that ratio of moles over liters going to be the same? No. That's what we call a baseball or a softball or curveball. Prevent you by the easy thing. They were expecting you to miss that. They were expecting you to say, oh, double the volume, double the molarity. So I need to prep you with that. No. Double the volume does not mean double the molarity. It just means double the number of moles. Well, here's the question. A saturated solution. So I start thinking I need to get X. A saturated solution by adding Z amount of lead 2 iodide to water. But this time I'm going to make a 2 molar solution. So obviously I'm adding it to more water. And it says, what are the molar concentrations of PB plus 2 and I minus in the solution? Justify your answer. So you can't just give values without justifying. My concentration of PB plus 2 is going to be 1.3 times 10 to the minus 3 molar. And my concentration of I minus is going to be 2.6 times 10 to the minus 3 molar. Because if KSP did not change, and it didn't, then X in water is not different. X will be the exact same value. And isn't PB plus 2 the value of X? And doesn't X technically come from your KSP? Now, yes, the number of moles is going to change, but the molarity, the X, is not. Okay, so I asked you a question, what can change the KSP? You said temperature. What can change solubility if I'm not changing temperature then? What can change the amount that does dissolve if I'm not changing temperature? Okay, if I look at, okay, but what can change the value of X? What can change the molarity that ends up dissolving? Yes, you're right, if we look at just the amount, the number of moles, or number of grams. But what can change the value of X when I go to get him from a KSP? What can change X? If the KSP doesn't change, what can change the value of X? KSP is not any different. So what can change the value of X? Thank you, Jordan. The common ion. Having a common ion instead of just having distilled water can change my value of X. And changing temperature, which will change my KSP, will change the value of X, but nothing else will. So the amount in moles or the amount in grams, yes, will change. But will X change if it's still just pure water? And I have to change the temperature? No. So those are kind of concepts that come from your reading, that come from you looking at questions and talking about them. No. All right, turn your paper over, please. Turn that paper over.